Hello guys, welcome back to another tutorial. Hit the bell icon button so that you don't miss out any tutorial.
Hi guys, welcome back. This is the very first module of the course Network Fundamentals, and this is your instructor Manjeet. So as part of the first module, we will be covering the basics of the network. What is the network, different types of networks, journey and growth of network technologies, and different network topologies. So let's first understand what actually the network is. In simple words, network is a group of two or more computing or digital devices connected to each other via some communication channel, or we can call media, with the purpose of sharing data and information. So now media can be of various types. It can be fiber optic, or it can be copper, wireless, Bluetooth, or even satellites. All these are examples of communication channels or media that we use for data communication. So now before we go to the next topic and discuss the different types of networks, I think we shall understand and go through the evolution of network technologies, how the technology evolved in last 4 to 5 decades. That will really help you understand the different types of network, and also you'll be able to understand why those different types of networks were there, what was the need of having the different types of networks. Okay, so let's start with the journey. If we talk about the early 1970s, the computer system used to be large boxes, large machines, and these systems used to work as standalone devices operating in isolation, independent from any other computer system. So during that time, even if you need to share a single file with your colleague in the same office, you were required to copy the file onto your floppy disk, and then you walk around in the office to reach out to that person to share the data. And there is an informal term for that kind of network, and it is called sneaker network. It literally means you put on your shoes and then you walk around in the office to share the information or data. So if you look at the image, I don't have any intention to promote Nike here. By chance I use the image and realize that it is a Nike logo there on the shoe, but you can ignore that. Nike is not paying a penny to me for this promotion, so just ignore that. So that was sneaker network, wherein manual effort was involved to share the information or data. But the business requirement was there. Business needed a solution wherein the data communication can be fast. So data can be shared efficiently and at a fast pace. And that eventually gave birth to local area networks, or LAN. In local area network, we interconnect multiple computer systems within the close proximity to share the resources and data. So gradually the usage of computer system grew in the business world, and soon it was obvious that even LANs are not going to be sufficient. There was a need to interconnect geographically separated networks, and that's the time when the Metropolitan Area Network MAN, or Wide Area Network WAN, or Internetwork, these network types came into the picture. So WAN could connect networks in the two different locations. That made it possible for the businesses to communicate with each other across the large distances. That actually brought the revolution in the business world. It was completely different from how the traditional businesses used to work. So undoubtedly this growth and journey was phenomenal. So if you go back and look at the computer systems of 1970s, they used to be large boxes with very less compute power, memory and storage. And if you compare with today's cell phones or smartphones or tablets, cell phone would have processing power and memory more than 100 times if we compare with those old computers. Even 5 or 6 inch mobile phone tablet would have around 6 GB of RAM, and this is a huge difference. So that's how the network technologies evolved in last 40 years. So now we have gone through the journey of network technologies. It's time to look at the different types of networks. So first in the category is PAN. So PAN is personal area network. So this is a small network that has limited connectivity and the coverage area. So generally these are private network where the accessibility is limited to one or very few users. Examples can be Bluetooth connectivity between the cell phone and any other Bluetooth enabled device, or wireless keyboards, wireless mouse that we use with laptop and computer systems. All these are examples of PANs, personal area network. So next comes the LAN. LAN is local area network. We already talked about the LAN. So it's a network that is generally owned and administratively controlled by a single body. So it is usually spread across the small area, campus, building, or an office. We can say that the LAN can spread across and connect devices in close proximity. So good example would be office network, where all end users with the digital cell phones or laptop computers are interconnected with the purpose of sharing the resources and data with each other. So there can be various different types of resources that can be shared over the LAN network. So printers, file servers, fax machines are a few examples. Now if we talk about the devices that can be there in a LAN network, so hub, router, switch, firewalls, or there are different types of devices that can be there in a LAN network. We'll cover the different type of devices, networking devices, in the upcoming sections. Now if we talk about the media, there can be different type of media possible in LAN network. It can be copper, UTP, cables, Wi-Fi, or it can be hybrid as well. So hybrid is a combination of two or more different types of media. For example, there might be the scenario that in a same LAN network you have the wireless infrastructure for the cell phones or laptops, and then you have the wired media for servers or the network devices or printers. So it is very much possible that wired and wireless media can coexist in the same LAN network. So that's it about the LAN. Now talking about the next type of network, that is Metropolitan Area Network, or we can call MAN. So it's generally expand throughout the MAN generally expands throughout the city. Such as cable TV network. So the cable TV network is a very good example. So which is there spread across the city or town. So now if we talk about the use case, where can we use MAN? So any organization, any institute, or any company who is looking at connecting the different locations and offices across the city or town, they can rely on MAN. So MAN can be one of the good solution for their requirement. So the next category is internetwork. Internetwork is basically network of networks. So even the internet is a type of internetwork. So internet is one big example of internetwork. It is a network of networks and the largest network in existence on this planet. So in simple words, internetwork is a larger network of smaller networks interconnected using some communication channels and protocols. So protocol might be a new term for you. So what is protocol? Protocol is a set of rules and policies defined to control and govern the data communication over the network. So there are various types of the protocols. We'll go through the protocols in upcoming sections. So now if we move further, there are different types of internetworks: intranet, extranet, and internet. So let's talk about these different types of internetworks. So intranet is an internetwork that is a private network or internal network of any organization. So any company or organization's internal network could be for its own employees only, to provide the services like HR system, payroll system, accounts, leave management system. So such services are generally provided by organizations on their private network to their own employees, so that no external user can access those services or can access that network. Now, if we talk about the extranet is an extension of internet. So there is external access to internet, but with the limited access and control. So for example, any organization may have some vendors, partners, business associates, and they might require some access to the internal network, intranet. In that case, external users will be given the limited access to the services in the intranet, that is called extranet. So now if we talk about the internet, as we all know, it is a public network, so anyone and everyone can access the network. So it is the largest network of networks. So all right guys, so I'll end this session here. So quick recap what we covered in this session. We discussed what is the network, we discussed what the definition of the network, evolution of network technologies, different types of network, local area network, wide area network, and metropolitan area network, or different types of internetworks, intranet, extranet, and internet. Hi guys, welcome back to the course Network Fundamentals. This is your instructor Manjeet. In the previous section, we talked about the different types of networks, and in this section, we are going to discuss the different types of network topologies. So there are various network topologies, various types of network topologies, but broadly we divide the topologies into two categories: the physical topology and the logical topology. The physical topology is the actual physical layout that depicts how the devices are connected to each other using the media, cables, or wires. And the logical topology, on the other hand, it references to the data flow in the network, how the data move or travel in the network. So it is very much possible that in a single network you may see a different physical and different logical topology. So we are going to cover this scenario later in this session. So now let's start and look at the different physical topologies. So first I'll talk about the bus topology. So the bus topology is the simplest design in which all the nodes are connecting to a single main backbone cable. So it is a very low cost design if we compare with the other topologies, but at the same time there are disadvantages as well. So in a bus topology, only one node can transmit the data at a time, because all the nodes are connected to the same media. So if two or more devices will try to transmit the data at the same time, then collision may happen. So what is collision? Collision is nothing but when two or more devices are sending the data at the same time, the signals may collide, and as the media is same, so signals may collide, and that situation of colliding the signals is called collision. So bus topology is suitable for the networks wherein very few devices are there. If we have more devices in the network, then there will be high chances of collision. So in fact, the high number of collisions in the network can bring down the whole network, and that high number of collisions is called the network storm, that can actually bring down the network. But otherwise, if you look at the bus topology, it is easy to understand, it is easy to implement, it is easy to expand as well, as there is a single cable in the backbone. If you need to expand, you just need to join the other cable to the one of the end of the existing cable, right? So this is bus topology. So now let's move to the ring topology. It is a more or less similar to bus topology, with the difference that in case of ring topology, the backbone cable connects to itself, or we can say both ends of main cable are connected to each other, forming a shape of ring or circle. So if you look at the diagram, it looks like a circle, right? So in order to provide the media access, the ring topology uses a method called token. So token revolves around in a ring and check with each node if that particular node has anything to transmit. Thus there will be less collision in ring topology, and it is better than bus topology in that sense. But now visualize a scenario wherein every node has something to transmit. That will bring the significant slowness in the network, because token will be holded by a node until or unless that node completes the data transmission, and then token will move to the next node, and again it will be holded by that node until that node completes the whole transmission. So it will bring the significant slowness in the network, and slowness may reach to a level where you are not even being able to use the network, work on the network. And there are some other disadvantages as well. The ring topology is difficult to troubleshoot. If you need to add or remove a single node in the network, it will impact the whole network connectivity. And in case there is a failure, one single node failure in the network, the whole network will see the impact. So these are the disadvantages of ring topology. So now let's move further. Let's talk about the star topology, wherein all the different nodes and systems on the network are connected to a central device, and in most of the cases it will be a switch. Star topology is generally widely used in LAN networks. So there will be a switch as the central device, wherein all the devices are connected to that switch. It's easy to troubleshoot. The advantage is it is easy to troubleshoot because all the devices are connected to switch with a different link, different cable. So as I mentioned earlier, it is widely used in LAN networks. Now, if we look at the disadvantages of star topology, there is a single point of failure in the network. If you look at the diagram again, there is a central device and all the nodes are connected to that central device. So if that central device or switch goes down, it will bring down the whole network. So that is one of the disadvantage of star topology, but still it is widely used in LAN networks. Now let's move further. Next is mesh topology. Mesh topology further have two different types: full mesh and partial mesh. So in full mesh topology, every node in the network is connected to every other node in the system. So what that would mean is there is a very high level of redundancy, because each device is connected to every other device on the network. If one link goes down, there will be very less impact on the overall network connectivity, because there will be some other path or route or some other way will be there to transmit the data. But the disadvantage is to make the full mesh network design, it involves high cost, because you need to connect every node to every other node in the network. So that's the reason it is generally used in WAN networks only. Now let's talk about the other type of mesh topology, that is partial mesh. So partial mesh, unlike a full mesh, each node is not connected to every other node, but some of the nodes are connected, so it doesn't give the full redundancy, but still there is a level of redundancy. And the advantage is partial mesh can be made at a low cost if we compare with the full mesh. So so far we have been discussing the physical topologies. Now let's talk about the logical topology. So if you look at the two designs on the screen, the first design and second design, both physically look like same. Both look like a star topology, wherein all the nodes are connecting to a central device, but actually logically this is not the case. So in the first design, it looks like a star, but actually it is a bus topology. So the bus functionality, the services provided by the bus topology, those services are, you can say, shrinked to that central box. That central box is providing us the functions of bus topology. So it is a bus topology, but it is looking like a star. But the data will flow in bus topology manner. So I hope it is clear to you. Physically it looks like a star, but the data will flow and transmit like a bus topology. So that's the difference between physical and logical topology. Now if you look at the second design on the right side, it again looks like a star topology, but it is a ring topology. The ring functionality is performed by that central box. So that's the difference. So now there are two more topologies that I'm going to cover. These are generally used in WAN designs only, but it is worth considering here as we are already talking about the topologies. So the first one is point-to-point. So in point-to-point topology, one node is connected to the other node without having any intermediate device in between. So it is directly connected to the other device. But in case of point-to-multipoint, you have one central node, and we can call that node as a hub node that connects to various other nodes, and we can say the other nodes as branch nodes. So if you look at the diagram, in point-to-point, branch nodes are connected to hub node, but there is no interconnectivity between branch nodes directly. So in this case, if any branch node needs to transmit data to another branch node, it will be first coming to hub node and then to respective branch. So this is the point-to-multipoint and point-to-point. So these are generally used in WAN networks. So that's it about the topologies, guys. So we covered in this session the various types of physical topologies: bus, ring, star, mesh topology, full mesh, and partial mesh topologies. We discussed what is the logical topology and how it is different than the physical topologies. We also covered WAN topologies, point-to-point and point-to-multipoint. So I'll end this session here.
Thank you for watching. Don't forget to subscribe to the channel. If you like the video, do give us a thumbs up and share it. Also check out amazing discounts and offers on our premium courses in the description below.